All right, looks like we're ready. So yeah, once again, hello everyone. Welcome to our webinar series. I'm Kory Kellum, and I will be talking to you today about LiDARMill version 2 and some great new feature updates we have. So if you are new to Phoenix LiDAR Systems, then welcome. And what we do is we specialize in survey-grade LiDAR systems that can be mounted on any moving platform, as well as fully automated cloud LiDAR post-processing. So why Phoenix LiDAR? Well, we were the first company to put LiDAR on a UAV system, and we continue to pioneer the industry. We had the first real-time 3D point cloud visualization software, first VTOL fixed-wing UAV LiDAR system, first cloud LiDAR post-processing platform, and the first UAV LiDAR terrain-following flight planner. Basically, if you have a surveying challenge, we have a surveying solution for you. It's that simple. So let's get into some new features offered in version 2 of LiDARMill. I'll begin with an introduction into what LiDARMill is and why you should choose to use it. So LiDARMill is the first cloud-based LiDAR post-processing platform. And it allows users to automate trajectory post-processing, LiDAR calibration, camera calibration, adjustment to ground control, and generate project reports, including data analytics and accuracy statistics. So why choose LiDARMill? Well, that's easy. It'll save you time, money, and headache. By uploading data to the cloud and processing data in the cloud, you eliminate the need for expensive processing computers and additional trajectory, LiDAR, and imagery software packages. All you do is set LiDARMill running, and it goes to work for you. Literally works while you sleep, while achieving reproducible data and results. And with your data not locked to one machine, LiDARMill offers you the ability and flexibility to share data seamlessly with anyone across the planet with an easy link. Just copy and pasting a link. So I'll begin with an overview of the LiDARMill workflow, if you're unfamiliar. And then I'll move on to some of the cool new features that LiDARMill 2 has, including imagery processing features, coordinate reference system features, ground control and adjustment, data products, automated detailed reporting, and I'll end on the Navlab and Spatial Fuser features. So we will begin with an overview of LiDARMill. So step 1 of LiDARMill, you went out and you captured data in the field and you came back to the office. This can be same day. You upload your data, upload all of your data from your rover, your reference station, upload it into LiDARMill. And then the next step is the post-processing phase. Step 2 being Navlab, our Navlab pipeline, which is trajectory post-processing. And then once you have a processed trajectory, then you can fuse your LiDAR and camera information, camera data to that trajectory and output data products. So that's step 3, Spatial Fuser, fusing data and outputting data products. And then the last stage is analyzing and sharing your data. And you can analyze it through the cloud viewer, so you can visualize it. Or we have the automated detailed report, so you can really get into accuracy statistics and that sort of thing. So the first new feature that I'd like to talk about is within step 1, the upload stage, and it's a Dropbox upload. So now you have the option to upload data directly from Dropbox, or you have the old school drag and drop method, as always, from your local computer. Another new upload feature is the ability to upload and process multiple missions simultaneously. As you can see here, we have our AOI-1 mission and our AOI-2 mission. So this is 2 different flights here. And as many flights as you have, LiDARMill 2 can handle them and process them all at once within the same project. Step 2 is our Navlab pipeline, which is our automated trajectory post-processing pipeline. And the first step there is to configure your rover. This is done, the rover is automatically configured from the nav file that is uploaded from your rover. So that's quick and easy. The next step is configuring the reference station. And that's another automated process because as soon as you load in your, I'll check that later. So once you load in your reference station data, it is automatically sent off to Opus and Trimble RTX and is post-processed, and the result is available within LiDARMill. And so the solution can be selected with the click of a button, and you have your post-processed reference station coordinate at that point. So then the last step of Navlab is to specify the output datum and start processing the pipeline. All right, so step 3 is using our spatial fuser pipeline, and that is the automated LiDAR and camera calibration pipeline, along with our data production or data product generation pipeline. So what it does is it fuses LiDAR to a post-process trajectory. It automatically classifies the point cloud created. It automatically calibrates cameras and then fuses RGB and or thermal data to the point cloud. And finally, it outputs data products in whichever coordinate reference system you wish. Step 4 is to analyze and share the processed data. And as I mentioned before, this can be done with the Phoenix Cloud Viewer, which is an easy to use tool shown here at the bottom right. And also a report is generated, and that report allows you to analyze details about your project, including accuracy statistics, hardware information, point cloud statistics, and much more. We'll get into that in more detail a little bit later. So I'll now move on to the imagery processing section and the new features available there. LiDARMill version 2 now gives you the ability to upload imagery collected during a mission, automatically calibrate the imagery, and then encode the final point cloud with RGB or thermal values, or both. Additionally, you can use LiDARMill to recalibrate your camera whenever you choose. You can do this for every mission if you so choose. LiDARMill will automatically optimize your camera parameters, including your camera sensor orientation, focal length, principal point, and lens distortion. So here is an example of a thermal encoded point cloud on the left and a RGB encoded point cloud on the right. processed in LiDARMill version 2 and displayed in our Phoenix's cloud viewer. And the cloud viewer will be shown in more detail a little bit later. Additionally, within the cloud viewer, you can also now view image locations, names, thumbnails, and camera frustrums. I will now move on to what I believe is the most important new feature of LiDARMill, the new robust coordinate reference system features, or CRS for short. While version 1 offered WGS84 as an output datum, version 2 allows you to select from any datum or projection with an EPS, having an EPS G code. If you need to get even more advanced with your CRS, no problem. You can input custom well-known text or proj strings to utilize literally any datum and projection you can think of. The CRS input and output options are available for ground control points, trajectory post-processing, and final LAS and output data products. LiDARMill now has the ability, has built-in geoid models that can easily be applied to your data. You can now seamlessly select a geoid model, and then LiDARMill will automatically convert your project from ellipsoidal elevations to orthometric elevations. Another exciting new feature is ground control. As we all know, absolute accuracy and ground truthing is a crucial part of providing survey-grade data products. Version 2 gives you the ability to input ground control points, or GCPs for short, and automatically generate an absolute accuracy report for you and your customers. While uploading GCPs, you first have the option to configure the datum, projection, epoch, units, and geoid model. LiDARMill will then display your GCPs on a 3D map for you to verify that your GCPs were input correctly. There are various map layers to select from, making it easy to verify the location of the GCPs. Once your GCPs are configured and verified, and when it comes time to output your final process point cloud, you'll have the option to automatically align your finalized point cloud to your GCPs. If you choose to use GCPs as independent checkpoints and do not wish to vertically align your point cloud to the input GCPs, you can leave the Align to GCP switch disabled. The image shown here has the Align to GCP switch enabled, so we just disable that. Another cool new feature is the creation of data products. So LiDARMill has always produced calibrated point clouds, but version 2 now offers calibrated, colorized, and classified point clouds. Classes include ground, unclassified, and noise or low point class. LiDARMill also outputs a downsampled DTM point cloud and can produce digital terrain models, digital surface models, and canopy height models, all in geotiff format. Contours can also be created in SHP, PRJ, and SHX formats. Now let's shift gears and take a sneak peek at the report, which will be covered in more detail later on after the slideshow. As you can see, there are many sections to the project report, including camera and LiDAR parameters, relative and absolute accuracy statistics, point cloud statistics, maps, and much more. Here's an example of a ground control accuracy report that is included in the project report. As you can see, vertical offsets between your surveyed GCPs and LiDAR data are computed, and then a statistical summary is generated, including industry standard metrics such as RMSEZ and NVA, which is non-vegetated vertical accuracy. And as seen in the upper right, a histogram of vertical distance errors is also included with each report. The report also includes the 10 maps listed here, where the upper image is an RGB map and the lower image shows a GCP separation map. I'll show these maps in more detail in a little bit. If you ever have a question about anything that's in the report, there is a handy link at the top right of each report that will redirect you to the help section shown here to clarify anything. We'll now move on to the new Navlab features. As you can see here, you can now import multiple missions into one project, and the project map view will assign each mission a distinct color. So here we have 4 flights. While setting up a Navlab pipeline, you now have the ability to select multiple nav files and reference station files and process all trajectories at the same time, as shown here. This is the main new feature improvement for Navlab. Spatial Fuser, on the other hand, has many new features. In just a moment, I will transition from the slideshow to a live viewing of the new LiDARMill, and I will show you the new Spatial Fuser configuration tabs in more detail. As for now, here's a list of the 8 configuration steps. First, what you need to do is configure your LiDAR ranging settings, then move on to automated flight line intervals, and then you can configure optimization parameters. Steps 4 through 6 are automated or automatically populated. And then step 7 is to configure your coordinate reference system output parameters for your LiDAR and data products. And step 8 would be to select which specific data products you wish to export. As you can see, the new version of LiDARMill is packed with new features that can save you time and money while providing repeatable and reliable results. To reiterate, with the new version of LiDARMill, you now have the options to upload data from Dropbox, process multiple missions at the same time, calibrate and fuse RGB and thermal imagery, input and output data in any CRS coordinate reference system desired, utilize ground control point surveys, generate data products, and finally output an all-encompassing detailed project report. So I will now move on to the live LiDARMill walkthrough. Okay, one of the first things I want to show is the new search bar up here. And if you type in something like Dominica here, you can search projects, pipelines, artifacts, files. I see some files have the word Dominica in them, job runs, missions, and you can just click on it and it will go right to it. So that's pretty handy. There's a new tab interface here. And I feel that's pretty intuitive. You basically work your way left to right. And so the first thing you're going to want to do is go to the missions tab. And this is where you load in all of your rover data. So here we have, and you can load in multiple flights from a full day of from flying missions. And all you need to do is click down here on this button, create new mission. And this is where you find that Dropbox upload interface. And it's as easy as clicking on that button and navigating to your files. Or you can drag and drop files in. Also, LiDARMill version 2 works with any version of Spatial Explorer or any rover version that you have, version 3 or 4 and 5, which are the latest. Then after you load in your missions, then you'll want to load in your reference station. And it's as easy as clicking on this button down here and loading in either a raw file, raw Rhinox file, I'm sorry, raw GNSS file, or a Rhinox file. And you can load in multiple reference stations. And you can see by these time intervals that these reference stations collected data at different times. Then we move on to our GCP tab. This specific project doesn't have GCPs loaded, so we'll go to a project that does. And the same loading style, you just click on create new GCP artifact down here. And I'll edit this artifact. Okay, so once you load in a GCP file, then now it's time to configure your coordinate reference system. So here we're using NAT83 2011 datum, UTM 11 north projection. We have our units in meters, and all of our observations are in ellipsoidal height. If they were not in ellipsoidal height, let's say I wanted to, if they were in an orthometric height, I could use NAVD88, and I could select a geoid, say geoid 12E, and whenever you go to select a geoid, if you hover over it, it'll show where that geoid is on the planet. And once you've configured your CRS, then you need to configure your column headers. So the first column, I selected name, then I have my X coordinate, Y coordinate, Z coordinate, and if you want to show all of your ground control, you can click show all. Once you have your GCPs input in the correct CRS, it will LiDARMill will automatically convert to WGS84, and that's strictly for viewing purposes for these map layers. But you can either use your mouse mouse wheel to scroll in and zoom, or you can simply double click to view your GCPs. And if this map layer isn't doing it for you, you can click on another map layer and just make sure they're relatively in the right location and not somewhere off in the ocean. Maybe you have they're somewhere off in the ocean, maybe you have your X and Y's mixed up, for example. Okay, and then you just hit accept, but I'll cancel that for right now. And so that leads us to our pipelines tab. So once all of our data has been loaded in, now we are ready to run a pipeline. And so once you click on a pipelines tab, there are two different kinds of pipelines that we can run, Navlab or Spatial Fuser. And we always run Navlab first to post-process our trajectory. Before you hop into Navlab, you could always double check your Opus report or your Trimble RTX report. And basically, if we click on Analyze Reference Station, Job Runs, we can view our Opus response, full Opus report, and Trimble RTX report, which is pretty handy. So let's start a Navlab pipeline. It's easy as clicking Navlab, and you can give it a specific name. And if you'd like an email response, you can always click that switch. And then you would enable every artifact that you wish to include in this Navlab pipeline. So if you had multiple nav files and multiple reference stations, select them all. In this case, we just have one of each. And by hitting next, I get to the three-step process I was referring to in the slides, where first you configure your navigation rover. And as you can see, this is automatically populated, the body time, U rotation, lever arm, etc. So you'll leave that and then hop to reference station. So now we're going to configure our reference station. So it's pretty slick. You can click here and select from your post-process trajectories, Opus NAD 83 2011, and you can see their error over here, or the ITRF 2014. Center point PPP is obviously less accurate than these post-processing services, and your average point is much less accurate. And if you don't want to use Opus or center point, and you have you set up over a known point, then you would click custom, and you would go through the workflow of selecting your epoch, geoid, horizontal coordinate system, vertical coordinate system units, inputting your position, antenna model, antenna height, measured to either your L1 phase center or your ARP, antenna reference point. So for this example, we'll just click Opus NAD 83, and once you input your reference station here, you can zoom in and verify that your reference station was set up in the correct location. At this point, there's just one more step for the Navlab pipeline, and that would be to configure your output datum, which we'd like NAD 83 2011. And yeah, then you just click finish, and then the pipeline will get started. We can then do a spatial fuser pipeline. Give it a name. Next. And then we can select everything that we want to fuse. So we want to select our post-process trajectory. We want to select our LiDAR data, our camera data, and I'll hop to this one for a fuser pipeline, which has ground control points. So if you have ground control points, they'll show up right here. And with all of your data enabled, you'll click next. And now we get to the 8-step configuration process for the fuser pipeline. So you can select your downward field of view, change that to 90 if you wish. You have minimum LiDAR range and maximum range. So if you want to go 3-meter minimum range, cut out landing gear, anything like that, you can. Then you can hop to flight lines and set the minimum duration for a flight line interval. So this optimization tab, you can do a lot of different kinds of optimization. You can optimize your trajectory, optimize laser orientation, laser ranging, and laser intrinsics. And you can perform the alignment to GCPs. And you can set, this says ignore GCPs outside of X standard deviations. So if you wanted to say ignore all GCPs outside of 3 standard deviations, you could. And you now have the choice of enabling photos within turns or leaving it disabled. Step 4, 5, and 6 are all automated. These values, these settings get automatically populated from your nav file. And same with the camera. If you wish to calibrate your camera automatically, you can select keep this enabled, or if you don't wish to calibrate your camera, you can disable it. And with step 7, you can configure your output CRS. So let's say I processed my trajectory in Navlab using ellipsoidal elevation. Then I don't want my output data product to be an ellipsoidal elevation here. So this is where you can change your output to be an orthometric. Metric elevations. And then step 8 is choosing which data products you want to export. So by selecting this, you get DSM, DEM, and CHM, the canopy height model. And if you enable contours, just select whichever contour interval you'd like. And click finish. So once your fuser pipeline has completed, it will create a cloud viewer pipeline. And then to go to your cloud viewer, all you have to do is, it's an easy one-click here. So I'll scroll down here and I will turn off our trajectory and the DTM layer. And I'll show you that this point cloud is colored by RGB. We can increase the point budget. And if we wanted to color this by thermal values, all we have to do is come down here and say, turn that RGB way down. And then the thermal values are stored in the NIR channel. Let's turn that on. And this project doesn't have GCPs, but if you, well, before I hop to the GCPs, we'll go back to, I'll turn off the point clouds and enable the DTM. And you can visualize your DTM there as well. But yeah, now we'll hop to a project with ground control. So yeah, if your project has ground control, then you have this ground control point layer that you can turn on and off, and it's a good good way to analyze your horizontal accuracy as well as vertical accuracy. And you can view photo locations. So this is a dual camera system. And I'll turn the ground control points off so it's less distracting. But here, if you click on a camera, then you can enable and disable your image locations, names, thumbnails, and frustums. I don't know. The overview tab will give you an overview of your project. So if you have multiple missions, it's colored by the various missions. And even a large mission like this loads pretty quickly. So let's open up the cloud viewer for this one. As we can see, there's quite a bit of load noise in this data set, but with the automated classification, we can easily disable that. All I have to do is come here to this classification filter and turn off low point. And all of that was done automatically in LiDARMill. can enable and disable your trajectories, DTM. And up your point budget. And the final thing I'd like to show is the data products that are produced. You can find them here. So once your fuser pipeline is finished, you can click on your LAS point cloud, and here are your contours that you can download, your DEM, DSM, CHM, and all these can be brought into freeware like QGIS, and it's all geo-referenced and can be visualized within these GIS softwares. So with that, we have about 15 minutes left, and I'd like to open it up to some questions. And thank you guys so much for listening to this webinar, and yeah, let's get some questions answered. Ben, are you there? Are you online?
Hey, Kory. Yes, I'm here. Thank you very much. It was a great presentation. Yeah, let's see what kind of questions, if there are any, or we can help you out. There was one question, if the slides will be available at the end of the webinar. I think we'll have a recording of the webinar available. So if you need the slides, just contact us. Another question is, pretty much there's many for geoid availability. For example, one is for Canada, one is for Europe, one is geoid AT. And yes, there's a database of geoids that we have. If there's one that you're missing, let us know and we'll add it. So yes, I don't see why there would be a geoid that we couldn't support. Then there is one more question. When will this launch? It is launched. So it's been going through quite a bit of testing over the last months. And yeah, I would say the last 4 months have been quite stable already. And we keep adding little features here and there. For example, recently we added, now that we added multiple missions, we added multiple trajectory optimization. So we don't just optimize one trajectory, but we optimize them all against each other. And those are the little additions and updates we're making in the process. So that wasn't there like 2 months ago. There's a question, where are you getting the thermal data? Yeah, that is a separate camera that's not captured by an RGB camera. Yes, it's a separate one. The LiDAR calibration, does the LiDAR calibration pipeline allow for flightline matching similar to TerraMatch? Yes, that's what we did here in the in this project. Actually, this is a multi-mission. Well, actually, we did that in all of the projects. Yeah, go ahead and show the Flightline matching report, Kory.
Yeah, sorry, that is one thing I forgot. The last thing was to go over this project report. And some of the great things in here, there's so much information in here. And I'll go through it. Up here at this here link, by the way, I'll just click on it to show you real quick. If you have any questions about the project report, just click here, and it'll give you detailed information about it. But I'll go back. So within this project report, you have all of your settings you used within your project, your hardware information for GNSS, LiDAR, rover, coordinate reference system information, trajectories, information about optimization.
Kory, scroll up a little bit. There was the information on how much the trajectory was shifted to align to GCPs. Right there, you can see that it was shifted down by 5 millimeters. Right. So that's because the align to GCP option was enabled.
And then I'll get to the Flightline calibration. And so yeah, you have your ground control report, and all of this is consistent with TerraSolid and what we're all used to seeing, as well as our strip-to-strip alignment and relative accuracy reporting. So here's the strip-to-strip alignment, and it's followed by our Flightline calibration. We also have point cloud statistics and a number of maps. So ellipsoidal altitude, intensity map, RGB, strip index, strip overlap, point density, and classification top up and top down and bottom up. As well as, I really like the GCP separation plot or map as well, showing each GCP colored by its vertical accuracy.
Thank you, Kory. Yeah, another question is, we have a third-party LiDAR sensor. Would the software be able to support our system? That's hard to say. If you would like us to have a look at that, go ahead and send us a data set, and yeah, we can have a look. Right now, it does not. Another question is, has there been any work checking the classification through LiDARMill versus TerraSolid, especially in heavily vegetated terrain? That's a great question. Yes, there has been lots of work. Yes, we did compare quite a lot, and of course, you always find data sets where automated classification will fail, and we're aware of that, and we don't plan on supporting 100% of all data sets. We're aiming for somewhere between 80 and 90%. We did run, of course, our classification over forests and mangroves and pretty much anything you come across, and I think it's very solid. But yes, there's always going to be examples where you would need to make manual corrections, especially in classification. And another question, for the DTM or other surface models, what filtering algorithm is being used and parameter settings? Are the details provided in a report of some sort? So for the DTM, so the bare earth model, of course, we use the ground class. So if you just look at the ground classification, that's what the DTM follows. And there really aren't many parameters that we need to use. And that's really the goal of LiDARMill, is to not offer hundreds of parameters, but to try and get it to process your data without having to tweak and tune. If you do run a project and you find that your DTM or DSM isn't what you would want it to be, then that's another beauty of LiDARMill. Just send us, if you go back to the LiDARMill UI, you can just click the question mark and enter a question. It becomes a support ticket, and because we have access to the data, we can immediately assess that and figure out if there's something wrong or how we can improve results. Yeah, application for thermal and LiDAR. So that's a great question. Honestly, we found there's quite a wide variety of applications. So we did this because we were asked quite a bit about thermal cameras, and there's people doing the classic leak detection on pipelines. There is people counting animals in the wild. There is energy efficiency applications. It's quite a lot, and we invested quite some time in getting the the thermal data to be accurate. So relative temperatures are easy, but getting the absolute temperatures down to 1, 2, 3 degrees, that's really hard. And sure, a thermal camera doesn't directly measure temperature, but it's just thermal radiation. But I think we've gotten to the point where we are in those, say, very few degrees. And so far, the customers are very happy with it. Yeah, and application-wise, sometimes we don't even know what people do with it, but it seems energy efficiency and pipeline inspection are pretty common. Animal counting, maybe not so much. Does it also work with vehicle-based scanning, other platforms? It's really optimized for aerial LiDAR. For example, we've had a couple of customers try out mobile mapping, and it does work. Usually the first attempt fails because if you remember the fuser options, we set a minimum distance of 10 meters and a downward field of view of 90 degrees. And if you think about those settings being used on a car, then you get exactly 0 points. But once you fix those 2 parameters, then yes, it works. It's not the testing we focus on. So we've had a couple of very happy results, but there's a lot of testing involved here, and we really focus our time on aerial LiDAR. So you're welcome to try it out, and if it works for you, then great. And sure, it'll come. When the software is doing the calibration, how is it doing the roll, pitch, and yaw corrections in the trajectory data? Well, that's based on observations. So essentially, you employ observations from neighboring strips and optimize to the trajectory so that these the correspondences. So if you say find a plane or a feature or something in neighboring flight lines, and you detect those and figure out, well, they're still 10 centimeters apart, then you try to optimize the trajectory to minimize those disagreements. The classic optimization problem. If this aligns to GCPs, does it rubber sheet or do an average type adjustment? So yeah, we built I think that may be in the report. Yeah, pretty much right. So it does a simple vertical offset. So it does build like an average offset from GCPs to point cloud, translates the trajectory, so everything moves with that, the imagery, the LiDAR, point cloud, and then does the statistics on the shifted point cloud. So no rubber sheeting. Then there's another one, let me see. Yeah, there's a question about how we compare GCPs to the point cloud. Let me try and get this right. So we mesh the ground. We have a ground model, and then find the vertical offset between GCP and ground. And of course, that does depend on us having an accurate ground model. But so far, we've tested this in the calibration site that you've seen. Is a little special in that the concept of ground over a dam is really kind of undefined. So we use that data set to argue about what ground is. But the more obvious data sets like this one or the thermal data set, yeah, works quite well. So essentially, if your DTM point cloud in the cloud viewer looks sane, then this is the representation of the same ground model we use for GCP matching. Is it possible to work with flight lines that aren't straight, similar to the options in Spatial Explorer? Great question. It's one of those compromises where we try to keep things simple. So technically, definitely possible. It's not exposed in the LiDARMill UI. If that's an issue, we can discuss adding those. It's always the compromise of getting in trouble for adding too many options and then getting in trouble for not offering those that a specific customer would like to use. But yes, for corridor mapping, I see the application, and we've had a couple of customers saying, well, I know exactly my options in Spatial Explorer because you can fine-tune the trajectory splitting. And if I hear this one more time, yes, we're going to add it. So the next one. Oh, here's a sad one. Somebody's asking for contact information because he hasn't been able to reach sales. That's sales@phoenixlidar.com, right?
That would be the best one right now. Either sales@phoenixlidar.com or info@phoenixlidar.com.
Or just call the office and give him some heat. And then there is a thank you. You're welcome. Is it possible to share a case study with thermal and LiDAR? We recently did have a flight with thermal and LiDAR. I don't think we can just share the data. David, can you say something about that?
Yeah, I mean, that client is currently under NDA and the data might not be shareable. However, we could maybe schedule a presentation, a conference call, so we can present the data to them and just show the section or some sample. Kory, what is your thoughts on this? I know you were part of that project and you're more aware of what the
about sharing that thermal and LiDAR. Yeah, as of now, it's completely NDA, and we cannot share with anybody. In fact, they have the data, and we've deleted it from our possession. So
okay, good to know.
Okay, the next question is, well, I mean, we can share the other data set that we showed in this presentation. That's our data, and yes, sure. Contact us, maybe support@phoenixlidar.com or sales at.
Yeah, sales.
Okay, and then sure, we can share maybe a last file or the link to the web viewer. Process time and product generation. I think it all depends on how crowded the processing queue is. When it does get crowded, we keep adding servers to the problem. Usually, I think this pipeline took 2 hours, the Fuser pipeline for these 4 flights. This is mini range of data, so it's not quite as dense. I think the thermal data that we showed was not quite sure, maybe 3-4 hours. So yeah, usually somewhere around there. We've also had somebody scan half the west coast of some southern European country. That took, I think, 44 hours or something. So it varies a lot with the size of the problem. File size limits, no, really. I think we have people uploading projects of 240 gigabytes was the worst I saw, the largest one. Yeah, it just takes a long time to upload. It's much faster if you import it from Dropbox, but then of course you have to upload it to Dropbox first. But yeah, there's really no limits. There's another, when integrating the images into the point cloud, is it using the trajectory from the LiDAR system to define the location of the camera at each image position? Yes, it does. So yes, of course, exposures are very much time-stamped. Then we use that information, camera calibration, and a lot of optimization to figure out how to get those colors into the accurate places of the point cloud. Is there any horizontal GCP calibration or just vertical? Yes, there is only vertical GCP adjustments. We're thinking about the problem. Here's another thank you. You're welcome. Somebody's asking that he is using LiDARMill but not seeing version 2. Please contact us so we can move you over to version 2. We're still leaving version 1 open for a while and asking people to migrate over to version 2. Another question, is there a processing delay still incurred for Opus usage when data is delivered within hours of acquisition? There is, so it can happen that Opus or Trimble doesn't reply, either with some somewhat random outage error that we sometimes receive from Opus. Then the Opus submission is rescheduled a couple of times. So if you come back from the field and immediately submit the reference station for analysis, then yes, that may happen. But as soon as Opus does have an answer, LiDARMill will have an answer. Yeah. Okay. Yeah, I think that's. Right. Somebody's asking for a webinar for power transmission lines. Thank you. We'll schedule one. And I think, let me scroll through here again, but I think we're coming to the end of it. Thank you guys very much. Those are some very good questions. Kory, you have anything to add?
No, I don't have anything to add. Thank you all for your time, and yeah, we appreciate it.
Thank you very much.